So let us talk about queues. Queues is also a data structure, linear data structure. So after stacks, we have queues in our syllabus. So queue na it has been asked in your beginning of the module, like module 2 also, and at the end also they have also like asked this queue again, like priority queues or something. So syllabus, like for previous year students, 2021 it will be different, for 2022 it will be different. So here let us discuss about queues. So queues we have like again multiple types of queues, like just ordinary queue, which is our normal queue. Linear queue is also nothing but ordinary queue. Okay, our linear queue is, I'll queue is like QUE. So I'll simply write queue is equals to ordinary queue itself. Okay, linear queue is also equal to ordinary queue, and then you have your circular, then you have double ended. Okay, double ended, one by one we'll see everything, and then priority. So now let us see about this queues. Okay, so queue is a linear data structure, so it follows first in first out. So which came first in the queue, that will be deleted first itself. In other terms, if you want to extend your definition, the item or the element which was there in the queue for the longest time will be deleted first. So this is a simple definition for queue. So let us directly move on to the queue operation. So I will be explaining you about only queues operations, that is how to insert, delete and display. Okay, so I think display is same for everything. Okay, so display is a common for all the queue, this I guess what to say, types of queues, because display like same as in linked list how it was common. So the same way here also it is common. Okay, so we will see only about insertion in ordinary. So we are doing about highlight OD. Okay, ordinary queue. So let us see now. First here like a program. So to declare a queue na, so simply you can write like hashtag define. You can either use like stack stack itself max size. So max, simply let me take max. Instead of writing that big thing, I'll simply write max. I'll say 5. Then int itself queue of max. Okay, only in one line I'll write my queue. So again let me simply write, let me write the remaining again, r comma f comma the item which I'll put, and then here ch will be used for I guess for traversal or some other thing. Okay, so this is this much is the necessary thing. Simply if you write in queue of max, then if you initialize int r equals to 0 minus 1 and f is equal to 0, only this much is also enough till this part. Okay, and this it's extra, this because this you can write in the inside the display or insert or delete function also, or anything like that. So it's not that much necessary to write inside this declaration of a queue itself. Okay, so this is over. So this is a simple part. Simply we'll say hashtag define max of some size, then int queue of that size. So queue is nothing but any name you can give. It's an array, right? Array type it is. So anything I can give for this queue. So now so see here, this is my queue. Okay, so what I said, size is 5. So 0 1 2 3 4. Okay, I am starting from 0, so that's why it will end at 4. Now what I have to do? So now initially for insertion, what we do now, we declare r equals to minus 1, which means what, my r na, it is here in the minus 1 position, which is not inside the queue. So same way in stack we used to see, if my s top equals to minus 1, stack is empty na. The same way in queue r is minus 1, then my queue is empty. So you can simply see check that condition. So now let us see for insert. Okay, void insert, with the diagram, with the help of diagram one by one I will be like showing you how to write. So first we will check full condition. So I won't be writing this, you can see the code here, this thing. So it's nothing but if r equals to max minus 1, so what is max? 5. What is 5 minus 1? 4, right? So if my r equals to 4, nothing but if my r is at its 4th location, then my queue is full. So that's how why I am writing max minus 1, because I declared 5, right? So 5 minus 1, it will be like that. So full condition is nothing but same as your stack also itself. Then we say return. Then the main thing. So here printf. So we'll say enter the element, enter element to insert in the queue. You can write that whole thing. So I'm just giving you an explanation. So I won't write the whole thing. Then scanf I have to do, %d comma ampersand item. This is ampersand. So as you can see inside here, I forgot to mention here what I will do, int item comma, again I have to declare, like I said, this will be anyhow declared inside the this function. So there in while declaring a queue, it's not that necessary to write, but still if you write, the one who correct your paper will think something or something like that. So scanf percentage ampersand item. So whatever item is there, it will be then. So what I will do, q of plus plus r. This is same as your stack, just I am putting q instead of stack. Plus plus r equals to item. So here we took some input. Okay, this is the output statement. Printf is output statement, scanf is input statement. So we took item as an input, so that item will be sent in this q of plus plus r equals to item. Nothing. If you didn't understand, just see that part again. So it's very simple. If not, also just see stack, same to same everything. Only this top here is nothing but my r here, and stack is nothing but my q here. Instead of stack, I wrote q here. Instead of top, I wrote r here. Same to same. Okay, so now see here. So it will check my r is not empty, right? So it is not max minus 1. So what will happen? Scanf. Suppose my item was 2. So q of plus plus r. First r will go here, then 2 inserted. Then my r will get again, if I call, it will come here. Then suppose I inserted 11. Okay, so leave 12. Same way 3, 4, 5 times. So here suppose 13, here 15, and here 19. Now you see my r is at 4th location. So this thing condition satisfies full condition. If my r equals to max minus 1, so it will come out. Okay, understood. So let me just rewrite. I won't erase this part. I will only erase this, because in deletion I will show with the same diagram how we delete. Okay, so now void delete. I will simply write del. Okay, so in void delete, what you do, first you have to check for empty condition. Empty condition. So empty condition, see here they have written this, or they have written this big thing. Okay, it's not necessary. What you do now, just here two conditions are taken. If f is greater than r, see this, if my f is greater than r, why, how it is like that means, suppose initially what is said, r equals to minus 1, right, and f equals to 0. So if r is minus 1, then my f is 0. So 0 is obviously greater than minus 1. So they mean like that. If my f is greater than r, this condition itself. If it is greater than r, then obviously stack is empty. Or else if you can simply write, if my r equals to minus 1, again my stack is empty. Okay. So and if, or else you have to set if they have used this condition. Okay, if f is equals to 0, both if equals to 0 and r equals to minus 1, you can use both the statements, but I'll be explaining few things here what will happen from which statement. Empty condition is over. Now what we'll do, we'll see how to delete an item. So we'll see, if empty condition, we'll say printf q is empty and we'll return out. Or else what we'll do, then I'll simply write printf element deleted, percentage d, simply write percentage d deleted. Okay, here q of f plus plus. Okay, they have written like this in the code. Okay, here either you can do like this, q of f plus plus, or else you can write q of f and then return q of f plus plus. So even you can do like this also. You can do like the same way we did in stack, return top minus minus we did, because they we used to used to delete the last element will get deleted first. So we were using only one variable top, but here it's not like that. Which I entered first will get deleted now. So you can either write like this, here only q of f you can write, and here return q of f plus plus and close like this, or else directly q of f plus plus, and this is not required. You can do like this also. So this is was about to delete. Now let us see how this works. So it is not empty. Now you see here main thing now, here what we have to say is, so see here my r is here. So both the condition, it is like my q is not empty now. Neither my f is greater than r, nor my f is 0 and r is minus 1. So deletion happened. Okay, deleted. Now again my f was here. Now my f will go here. It will get deleted. It will come here, delete. It will come here, delete. It will come here. Now you see here, as you can see, my r is still at 4. This got deleted, this got deleted, this got deleted. My f came here now. F is here, and I deleted this also. Now if you see here, even though my stack is, my queue is empty here, but if you want to insert, you cannot insert. Why? Because let me write here, what is a full condition? If r equals to max minus 1, you can see, right? So if r equals to max minus 1, it means my queue is empty. Queue is full, sorry. So see here, my r didn't move itself, it didn't change itself, my r is still at this location, even though the queue is empty. But according to the statement, we cannot still add any item to the list, this queue. So this is the main disadvantage of your ordinary queue, where even though you have a free space, empty space, you cannot insert an element or an item. So to overcome this drawback, we move on to a circular queue and circular queue. Okay, so in circular queue, what happens is we use the term count variable. Okay, so suppose in circular queue, draw one circle and draw one small circle. That's it. Then you simply put line. So this will be here 0. Let me put 1, 2, 3, and 4. So initially here will be my count, COU and take count, and my F, and R equals to minus 1. Okay. So now again same thing. What we do? Here we do the same thing for insert. So we check full condition. So they will check full. If r equals to max minus 1, so full condition. So let us start. So I will simply write my count and f is here. Okay. So what I will do, I will, like same way I will declare q itself. Okay. So for circular queue, let me simply write CQ of max. Okay. Here I have defined that hashtag define here 5. So here CQ of max. So what I will do, int count equals to 0. Okay. Int comma r equals to minus 1 comma f equals to 0. Okay. Don't declare here, you can declare here, or like I said, you can declare inside the main function also. So now what happens, let us start our insertion. Now see here, first insertion, void insert. Okay. So now what happens, sorry, this won't come, right? So here full condition, I won't be writing because it's the same every time, it's the same itself. So just see and wherever it is, just see and write. It is same as stack and it is same as queues. For both the full condition is same. So here what I do, then if it is not full, right? So what I do, r equals to r plus 1. Okay, r plus 1 mod max size. Okay. So from this now I will return the value of r, then q of r CQ, right, is equals to item I will do of. Here you have to write a printf enter item scanf percentage d item, you have to write that. Okay. So printf and scanf, so that you write, okay, you understood, right? So I will write here, okay, r plus 1, r is equals to r plus 1. Here printf condition, here scanf condition, here full. Okay. So I will be writing only the main part, only the difference thing, because that's more than enough for you to understand. So what happens now, I will explain this what has happened here. Okay, this is not bracket, this is your C. So now see here, I will simply delete, erase this part. So what was my r? R was minus 1. Minus 1 plus 1 is equals to 0. Okay. Now 0 mod max 5. 0 mod 5 is nothing but 0 itself. So the value of r returned was 0. So what will happen? My item will be inserted here. Suppose it was, let me take 4, right? From 5 I will take 5. So I inserted an item in that printf scanf. I gave 5. So it inserted here. Now my count will get incremented. Count plus plus. Okay. So now my count was at 0th location. My count will go to first location. Okay. Count. Now again, now what will happen? R equals to r plus 1 mod max. Again if I call the insertion, r is at 0 now. 0 plus 1 mod 5. So 0 plus 1 is nothing but 1 again. So 1 mod 5 is nothing but 1 again. Okay, 1 mod 5 is 1. How 1 means? Obviously it will be 1 itself, because I will say how to understand. I will say a simple thing. N mod m is equals to n itself until n is less than m. Less than not equal, less than equal to not, less than m. So suppose whatever the number we are dividing here, from this n, if until it is less than m, we will be getting n itself as our mod. If it is m equals to it is, if n is equals to m na, we will get 1, okay, like that you understand. So 1 mod phi is nothing but 1 itself until, so 2 mod phi equals to 2, 3 mod phi equals to 3, 4 mod phi equals to phi itself. Now 5 mod phi equals to 1, okay. So now what happens, okay, now let us see here. Now my r was at here, so I call the insert function. I have just kept this for reference. So my r was at 0. Now see, 0 plus 1 is 1, 1 mod 5. So here I again insert, let me suppose I have inserted 6. Now my count will be here at second location. Again r plus 1 mod max. Now r is 1, 1 plus 1 2. So 2 mod 5 is 2 itself. So here I will add. See, similarly 7, 8, 9. So okay, understood. Like this I inserted items now. Now you can see r is my 4, right. So here full condition will be always there, right. So my full condition, so r is max minus 1, so it will come out, so I cannot insert anymore. Now whereas coming to deletion part, anyhow f is equals to 0 itself, my f. So first I will check empty condition. Empty condition is checked first. For void del I will write delete, okay. Then what I will do, I will say printf deleted element is percentage d like in printf comma I will write like that. So let us see here. First what I will do, I will print what element is deleting. Printf I will do percentage d I will give cq of f I will write, okay. Then I will close it. Then f is equals to f plus 1 same mod max, okay. So here what happens, I can delete like this, f plus 1 mod max, yeah. Then I will return, I will delete like that. This printf element is deleted like that. So this is how you do for your same way. Instead of r, we will be putting like this f plus 1 mod max. So this item will get deleted now, okay. So here so one thing, sorry, here I forgot to mention. So in void, in empty full condition na, we won't put if r equals to max minus 1, we will write if count equals to max minus 1, okay. So if my count equals to max minus 1, then only and here a count minus minus, count minus minus, okay. So let me say you again. So I will keep this here and I will write here. Now what happens, so if I say if count equals to max minus 1, then this is my full condition, okay. You see, right. So here it is full, that part you write. For printf, enter that element simply, then I am writing scanf percentage d ampersand item, okay. So what is happening, r is equals to r plus 1 mod max. So one by one like that you saw it got entered. Similarly for deletion, what will happen, I will check empty condition. If same what you saw, f equals to 0, it is empty, or if f equals to 0 and f is greater than r, it is empty, or if f equals 0 and r equals to minus 1, it is empty. So now here what happens, here count, right. So now see here, count equals to sorry, so my suppose this was 5, right. Now see here, it's very simple. I only one mistake I did was this, instead of r count will come, nothing else is wrong now. So in this empty condition I checked f is greater than 0, or if f equals to 0, not 0 here r, and r equals to minus 1. So now see, this is the empty you write off. For delete printf I will write deleted element is, so I will write off percentage d deleted, okay. Then I will write cq of f. Now what will happen, f is equals to f plus 1 same mod, I am writing mod, okay. I like this, modulus max, okay. Then I will decrement my count, count minus minus, okay. So now see here, my f got so see f was 0. So after deleting, first I will delete, then I'll send my f. So if deletion happened here, okay, deletion. Now f plus 1 is 0 plus 1 is nothing but your 1. 1 mod max, 1 mod phi is 1 itself. So my f from 0, now it will be in my first location. Now see here how we can delete here now, okay. So now see how we can add. Now this f, this part got deleted. Now see here how we can add one item here. Now one item is delete. As soon as we delete, now we will call insert function. Now see what will happen. You will check if count equals to max minus 1. What is my count now? It was what here 4. So my count is now 3. Okay, so my count was at 4 na. So my count will be here now 3. COUNT, count is equals to 3. Okay, if here it was full 4 until this got deleted, as soon as I deleted, I decremented here. So my count is here now. So now what will happen? Here it will check. Count equals to, no, it is not. So what I will do? R equals to R plus 1 mod max. Now what is my R? My R is 4. Now see here what happens. R is 4. 4 plus 1 is nothing but my 5. 5 modulus 5. So in reminder by 5 modulus 5 is equals to 0 itself, right? So again my whatever printf scanf I do, R plus 1 mod 5. So my R value came 0. So I see in 0th location again my R came. So suppose I am entering 5 itself again, or else we will take 10. Understood? Now see here, my f is here now. Okay, my f is here. I will call this delete function, and here my count here count plus plus. Sorry, I forgot to mention here count plus plus. So again now my count instead of third location, now again it is in fourth location. Again I call delete. So f my f was 1. So 6 will get deleted. Okay, my f was at 1. Now my f will be at 2. Okay, here it's empty. Again my count become minus minus. So my count will be 3. Again I will say R equals to R plus 1 mod 5. So what is R? R is 0 now. Okay, R is 0 again. So 0 plus 1 is what? 1. 1 mod 5 is what? 1 itself. So again something will get entered here. So this is your advantage of circular queue, where you can add or delete even in the empty space. Here you won't be facing the problem where it will go empty. Okay, so let us see about this display. For everything display will be same. So what we will do for display is, first we will check for empty condition. Okay, empty condition every time, because there is nothing to if though there is nothing in the queue, we cannot display anything. Then what we will do, printf I write contents of QR that you write off. Now loop, okay, for int I equals to f. Okay, so I will explain you with both circular queue and this. Okay, so my f is here at 0. Okay, suppose my R is here now. So 0, 1, 2, 3, 4, and here I will write 5, 6, 7, 8, 9. These are my content. So if int f equals to I equals to f, so my I is here now. Okay, comma, like this, not comma, semicolon, then I less than equals to R, then I plus plus. Okay, so now what will happen? Now again here printf statement percentage d q of I. Okay, that's it. So now see here I equals 0. First printf. Okay, this happens. So I equals to f, I less than R, yeah, true. I is at 0, I is less than R is 4, true. So I plus plus. First it will print display here. Okay, so it will display this, and now it will go here. From 0 it went here. Then again same way, it will come here, it will come here, it will come here. So the less than equal to R, it will display. Now after that it will get incremented. So my I is 5 now, R is 4. Is it less than equal to 4? No, it is greater, it will come out. So this is how you display. For display is same for everything. Oh sorry, I forgot to like tell about circular. Anyhow, let us do again. For circular queue, how you display na, it's simple itself. So suppose my f is here, right, at 0 location, 0, 1, this is 2, this is 3, this is 4. Beginning I said display is same for all, but just ignore that. Okay, so my count is 4 now. Okay, my R is also at 4. First you have to check the empty condition. Okay, empty condition, how you check if count equals to 0 or yeah, count equals to 0 means there is nothing in your list. If count equals to max minus 1, it is full. So what I do now, I say int j equals to f. I didn't write here 5, 6, 7, 8, 9. So how we do temp equals to that head in linked list, like that I'll assign my j equals to this place f, wherever f is there my j will be there. Now I'll write for loop for int I equals to 0, I less than equal to count I plus plus. Okay, then what I will do in printf percentage d, I'll print my q of j, not I. Then what I will do, I should increment j, right? J equals to j plus 1 mod max, or you can say mod yeah, max itself, size itself will come, right? Same thing. Okay, so now let us see how this works. So my I is 0 now and my count is 4. Okay, so I equals to 0, it's less than 4, so printf and it will increment, right? So here it was here, now it will go here. So I is 1, 2, 3, 4. So okay, so until it is equal to 4, my I 5 times my I will get increment. The same way my j also 5 times it will go here, 1, 2, 3, 4. So 5 times it will display and get incremented, and my count will be decreasing from 4. It will from it was see here my count will be 4, here my count will be 3, here count will be 2, here count will be 1, and here it will become 0. So until here so count, if count is 0 na, so what will happen, my what to say full condition satisfies and will come out of the loop. So this is how what you have to do for your circular queue display function. I hope you understood. Any doubts you can just ask in the comment and I'll try to correct it. If it is late, if you are asking like at the end moment nothing can be done, you can just contact me directly. So nothing else is there. So that's all for your circular queue and your ordinary queue, and I'll explain double queue and periodic queue in the next lecture. Thank you.